Alright, so it's actually been brought to my attention that people still don't understand the topic of electrolysis, and that's a really big topic when we talk about GCSE and A-level chemistry. You need to understand it to pass your exam, guys. So in today's video, I'm going to just be teaching you the basic concepts of electrolysis. Hopefully you understand it. My name is Ruth. I'm a GCSE and A-level science and maths tutor. Okay, let's get into the video. So now to assist me in the video today is my pocket-sized whiteboard, so bear with me. Alright, so now if we were talking about electrolysis, how would I start off? Obviously the definition. What is electrolysis? Electrolysis is the decomposition, or, layman's terms, the breakdown of an ionic compound using an electric current. So we could take an ionic compound, the very, very common one, sodium chloride, NaCl. So if I take sodium chloride here, and let's say I dissolve it in water or something, its ions that it's going to yield or produce would be sodium, Na+, and chloride ions, Cl-. I could give you another ionic compound, for example. If I were to immerse potassium chloride in water, then it becomes aqueous. It's no longer solid, is it? So it's going to form K+ ion as well as Cl- ion. So KCl is going to be broken down into K+ and Cl-. Very simple, very easy. Now for electrolysis, you need to know specifically about what we call an electrolytic cell. So now what is an electrolytic cell? I'm going to show you. An electrolytic cell comprises of the following. So I've actually taken out time to draw an electrolytic cell, and we're going to see what it comprises of. Number one, it comprises of an electrolyte solution. An electrolyte solution is just basically a solution, so a liquid that contains positive and negative free ions. So remember, in electrolysis we're breaking down an ionic compound. So it contains, for the example of sodium chloride, the electrolyte solution would contain positive sodium ions and negative chloride ions. So if you see here, there's Na+, plus, there's also Cl-, minus. Very, very basic, very, very simple. Also, in an electrolytic cell, what are you going to find? You're going to find what we call electrodes. Now, what exactly are electrodes? Electrodes could be metal or they could be graphite. They're basically just substances through which electric current is going to pass through. That's why they need to be either a metal or a graphite, so that they can actually conduct electricity. Does that make sense? So we have two electrodes specifically. We've got the cathode and the anode. Now they differ just a little bit, and I'll explain how and why. Now the cathode is what we call the negative electrode. So because it's negative, due to basic laws that I'm sure they would have taught you in year 7, opposites attract, right? So the cathode is going to be drawing to itself positive ions. So the cathode is negative. In the example that we used, sodium chloride, positive sodium ions would be drawn to the cathode. Now we have the second electrode, which is the positive electrode, the anode. Now the anode, because it's positive, again remember, opposites attract. So now negative chloride ions down here, they're going to be attracted to the anode. That's just the long and short. The last piece of the electrolytic cell that you need to know is obviously the power supply. The power supply, it could be a cell, it could be a battery. It's really just down to what the question gives you and asks you for. Now that we have let's say the electrolytic cell sorted, let's quickly go over why ionic compounds are used for electrolysis specifically. Again, if we take a look at my pocket-sized whiteboard and we see the breakdown of sodium chloride into sodium and chlorine, you notice that compounds are only actually able to conduct electricity because they have these free ions to carry around charge. If a compound doesn't have these free ions, then it doesn't have the ability to carry around charge. Now, if we look at covalent compounds, they don't really, let's say, produce ions, whether it be positive or negative when they're broken down. So for that reason, they're not able to conduct electricity. However, ionic compounds, when aqueous or molten, just meaning when they're dissolved, they produce these positive and negative ions, and so for that reason they're able to conduct charge. Now in an exam question they could ask you, okay, these positive sodium, negative chloride ions, what if, okay, they were used to form solid sodium chloride? Solid sodium chloride, would it be able to form, let's say, conduct electricity? Would solid sodium chloride be able to conduct electricity? The answer would be no, because when solid, it's just sodium chloride. There are no free ions. But when I immerse it in water, let's say I dissolve it in water, I yield sodium plus and chloride negative. if that makes sense. So that's why ionic compounds are used specifically. Now the last thing we're going to talk about or touch on in this electrolysis video is the discharge or movement of ions to the different electrodes. I already kind of talked about this earlier. Positive sodium is going to travel all the way up to the negative cathode. Negative chlorine is going to travel all the way up to the positive anode. And they're going to form different products. Now, I'm sure you've seen in maybe class or maybe exam papers, they ask you to predict the product that's going to be formed at either the anode or the cathode. What they mean by that is basically, okay, so when these positive and negative ions move to either the anode or the cathode, what product do they form? Usually, when these positive or negative ions move to either electrode, they're either going to gain or lose an electron based upon their charge. Now, think of it like this. When I want to make a product at either the anode or the cathode, I'm trying to get the product back to zero. So if you can see, sodium is positive, chlorine is negative, so they both contain a charge. When I produce a product at the whatever electrode I'm producing, whether it be the anode or the cathode, I do not want it to have a charge. So now, this just goes back to the basic laws of how we produce ions. Sodium is positive, so when we lose an electron, we form a positive ion. So if we gain an electron, we are going to cancel out that positive ion. So sodium, if you see really closely here, sodium is going to have an electron added to it. And once we add an electron to sodium, we're going to form sodium solid. So now we formed solid sodium at the negative cathode. That's the product that's going to be formed at the cathode. Now let's look at the positive anode. Remember, opposites attract, so chlorine is attracted to the anode. So again, remember, chloride is negative. So because I've gained an electron to form the negative ion, I'm going to want to lose an electron to form the neutral charge. So if I take chlorine here, I'm basically just going to have it lose an electron, and it's going to form chlorine gas. Now you may see, obviously it says 2Cl minus here forms Cl2 and 2E minus. If you watch the next video on half equations, you'll understand a bit more about that. But the basic concept about electrolysis is I'm using electricity to break down an ionic compound. When I break down an ionic compound, I form a positive and a negative ion. The positive ion travels to the negative electrode, the cathode. The negative ion travels to the positive electrode, the anode, and then they form neutral products. Okay, that was a bit brief and a bit fast, but I hope that made sense to you guys. Alright, if you watch the video on half equations, you'll understand how to balance these equations just a bit better. Thank you so much for watching this video, and I hope to see you again. Okay, bye-bye.